Hello everyone. Welcome to the solution of LeetCode problem 215 named kth largest element in the array. In this problem, we are given an integer array and an integer k, and we have to return the kth largest element of this array. Anyways, the requirement of this question is we don't have to use any sorting function, or we have to implement the algorithm without any sorting. Anyways, I hope you understood the problem statement. Now let's move on to the example. In the first example, the given input vector has 6 elements, which is 3, 2, 1, 5, 6, and 4. And we have to find the second largest element, which is 5 here. 6 is the largest and 5 is the second largest element on this array. Anyways, for the example 2, this is the given input vector, and we have to find the fourth largest element of this array. Here, the fourth largest element of this array is 4. I hope you understood the example. Now let's move on to the constraint. Here, the array length can be in between 1 to 10 to the power 5, and each of the array element can be in between minus 10 to the power 4 to 10 to the power 4. I hope you understood the constraint. Now let's move on to the solution. In this problem, the main requirement is that we don't have to use any sorting function. So let's understand how can we solve this problem without any sorting function. I hope everybody knows the concept of heap data structure. There are two kinds of heap, which is max heap and min heap. To solve this problem, we are using min heap. The main concept of the min heap is min heap store the minimum element into the top position of the heap. Suppose min heap store the element which is 3, 2, and 1 in this manner. And alternatively, max heap will store the value in 1, 2, 3 in this manner. So we can say that min heap puts the minimum value at the top of the heap, and max heap puts the maximum value at the top of the heap. I hope the concept of heap is clear. Now let's move on to the actual algorithm to solve this problem. Now, to understand the algorithm, we have taken the first example. Here in the first example, we have 6 elements, which is 3, 2, 1, 5, 6, and 4. And we have to find the second largest element. So here, the value of k is 2. Now, we have to iterate a for loop and put each of the array element into the min heap. Now, currently, we are at the first element, which is 3. So we have to put 3 here. Now, currently we are at the second element, which is 2. And we have to insert 2 here. Here, the order remains same because 2 is less than 3. And we are using min heap. So minimum amount or the minimum number is in the top position. Now, we are in the position 3 and the current value is 1. So again, we have to insert 1 into the min heap. So 1 is inserted here. Now we are at the element 5. So we have to insert the value 5 into the min heap. But here the order will definitely become changed. Why? If we insert 5 here, it is violating the concept of min heap. So if we insert 5, the order will be 5, 3, 2, and 1. The value of 5 will go to the bottom of the heap. Anyways, now currently we are at the element 6. And again, if we put the element 6 into the heap, then the order will also become changed. So here, the heap content is 6, 5, 3, 2, and 1. Here, the element 6 will go to the bottom of the heap because it is the largest among all of them. Now, currently, We are at the last element, which is 4. So again, we have to insert 4 into the heap. And if we insert 4 into the heap, the order of the heap will also change. And currently, our heap will become 6, 5, 4, 3, 2, 1. Okay, now we have inserted all of the input element into the heap. So now we have to find the second largest element from this heap. How can we do it? We can simply calculate the length of the array, which is 6, and the k is 2 given. So if we subtract 2 from 6, we will find 4. Now we have to discard the top 4 element from our heap. So if we discard the top 4 element, 1 will be discarded, 2 will be discarded, 3 will be discarded, and 4 will be discarded. And our present heap will contains only the value 5 and 6. Now, if we get the top element from our heap, we will get the value 5, which is exactly our expected answer. So now we can easily extract the top element by using the top method of the heap. So fine, that's the algorithm. I hope you understood the algorithm. Now let's move on to the code. The code is pretty simple. At first, we are given a function named find kth largest. The parameter of this function is the input vector and the integer k, and we have to find the kth largest element of this vector. Here, at first we store the size of the vector into a variable n, and we are declaring a min heap. This is the syntax of declaring a min heap. After that, we have to put all of the array element into the heap, and after putting all of the array element into the heap, we have to remove the n minus k element from the heap using this while loop. After that, the remaining heap only contains the k element, and as we are using the min heap, the minimum element will be presented at the top of the heap. So to gain the kth largest element of this heap, we can simply use the top method, which is pq.top. And finally, we have to return it. I hope you understood the algorithm. Now let's move on to the time and space complexity analysis of this program. Basically, the time complexity of this solution is big O of n log n, where n is the number of element in the vector A. This is because the priority queue operations, pushing and popping element, takes log n time, and we perform these operations for all of the n elements. So the final time complexity is big O of n log n. Anyways, the space complexity of this program is big O of n, where n is the number of element in the vector A. This is because the priority queue stores all the elements from the vector A. So we can say that in the worst case, the space complexity is big O of n. I hope you understood the time and space complexity analysis of this program. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.